All right, we're going to talk first about area. So can somebody tell me what, if I say find the area, what does that mean to do? What are you trying to figure out? Andrew.
Isn't it like finding out how much whatever unit space is in the shape?
How much unit space is in the shape? That sounds good. Can anybody add to that or do it, say it a little differently? What is area? Not quite. Area and volume are a little bit different. Good idea. Yeah.
Find the whole of the shape.
Find the whole of the shape. Okay, I like that. Right? It's how much space it covers. And the way that we talk about that is, our definition is the number of square units that a shape encloses. All right, so there's some information there. So the number of square units a figure encloses. Let's talk about the things square units first. So, square units, I want to start with the square. Now, because it's a geometry class, is that necessarily a square yet? No. What can you tell me about that red shape? What's that? It needs to have tick marks. Right now, what would the name be for that? What can you tell me that name is? Because of the cube. Quadrilateral. All we know is it's quadrilateral. All right? What is it now? It's not a square yet. It's not a rectangle yet. Begins with an R. It's a rhombus. Okay, it has four sides that are the same. All right, now what is it?
Square.
Now it's a square. I know it's a square. All right, so it's a square unit. I have the square part. What's the unit part? What do you think a unit is? Measurement. A measurement is specifically of a number. What number do you think is a unit? How far is a unit?
0 and 1.
Very close.
Well, it's how much, like, sort of mass is inside of the object you are trying to find the area.
Okay, close. Close. A unit would be a distance of 1. So we have a unit is 1. All right? So if it's square and that side's 1, oops, go back. If that side's 1, what's the other side going to be? 1. So what's the area of that shape? 1 what? 1 square unit. All right. That's our building block. That's where we start from. All right? So 1 square unit, we want to know how many of those will fit into a figure, and that we call the area. All right. So, if we look at rectangles and squares, these are nice because they fit square units pretty well. All right. Do we know that the one on the left is a rectangle? No. You don't know it. It looks like it, but in geometry we're going to be specific about what it takes to be these figures. So can somebody tell me what I would need to do to that shape on the left to make it a rectangle?
Put like 1 tick mark on the left, 1 tick mark on the right side, and put 2 on the top.
Okay.
And 2 on the bottom.
All right. So if I was to add to it, I would need to put 1 on top, 2 there, 2 there. That makes it a rectangle with the 90-degree angles. Okay? We call the bottom piece base, B, top piece H, height. Sometimes length and width. We'll move them interchangeably. B and H is kind of a more general naming structure. And then my shape on the right, again, isn't yet a square. Right now it's a quadrilateral. Now it's a rhombus. And now it's a square. Okay? And I named the sides S. And they're the same as the square. All right. So what we're going to do is we're going to figure out how many square units fit in those things. And the way that you can think about it is if I started going across, if I took a square that was 1 long and put it across here, I would fit it in B times. And then if I went up the other way, it would go in h times. And so my area is going to be this row times h, or just b times h. All right, so that's the formula that we've used to. We're taking square units, we're putting them in, it fits across b times, it goes up h times. Can somebody raise their hand and tell me what they think the area of the square is going to be? Don't overthink it.
S squared.
Yeah, s squared. I multiply. It goes in s across and s up. If I counted them up, I would get s times s, which means s squared. All right, so you've seen all this before. It's nothing new. We're going to expand on it down the road, but we want to have an understanding. What I really hope you come away from today with is area is square units. Okay? All right. The perimeter is all the way around. Well, if I go all the way around, if I start here in this corner, I go b plus h plus b plus h. If I simplify my terms, b plus b is known as 2b, h plus h is known as 2h. Now, is perimeter measured in square units? No. It's a linear unit. Okay? So if my unit is feet, my perimeter is going to be in feet. If my unit is miles, my perimeter is miles. My area would be square miles. My area would be square feet. All right? And then the perimeter for the square, s plus s plus s plus s, known as 4s. All right. Nod your head if it's easy so far. Good. All right. Let's talk circles for a second. There's my circle. Can anybody give me a definition for what a circle is? Yeah, no, what do you think?
Shape with no sides.
Okay. It doesn't have sides as we think of as lines, right? Like that. Alex?
The shape that amounts to 360 degrees.
Okay, so go all the way around, it's 360 degrees. Emily, you have some of that? No?
I would just say a roll shape.
Okay. Good. What are some of the pieces that you know about the circle? You know all the way across is diameter, halfway across is radius. In the middle, what do we call the thing in the middle? The blank of the circle. Somebody said it. Center. All right? So it's all the points that are going to be the same distance from the center. So there's my diameter. There's my radius. It's half my diameter. So if my diameter is 16, what's my radius?
8.
8. If my radius is 2.5, what's my diameter?
5.
5. Good. All the way around. All the circumference. So are the units on circumference going to be units squared or linear units? Is it more like perimeter or more like area? More like perimeter. So we're going to have area or units of linear units. Okay. Down the road, we'll figure out why this is true. But we really kind of need some calculus to get the real answer. But our circumference is this thing pi times the diameter. Can anybody give me a common number that's used for pi? 3.14. People have memorized it to obscene digits. Anybody want to guess at the world record? Good luck. The world record for reciting pi. Anybody 100, right? More than 400.
800,000.
More than 800.
10,000.
More than 10,000.
8,000.
Less than 2 million.
A million.
Less than
200,000.
It is a little bit over 40,000 decimal places. So somebody memorized pi to about 40,000 decimal places. So pi never ends and never repeats. But people spend a lot of time worrying about it. All right. We will usually use 3.14 or 22 over 7. Either one of those works. And I have squiggly little equal signs. It means approximately. It means about. Okay? Because pi really keeps going. It's not equal to 3.14. It's approximately 3.14.
Are we
All right.
celebrate Pi Day?
Are we? We'll see.
Yeah, we should.
To
All right.
celebrate Pi Day is usually we bring pie or something to that circle.
No.
We'll cross that bridge when we come to it. All right. Area. Anybody remember the area formula? I hope somebody does. Radius squared times our friend pi. All right. Or pi r squared. Oops, I'll go back.
Oh,
So two things, two formulas: circumference, 2 pi r, or diameter pi. Area, pi r squared. And I'll get square units for area. And if you have a calculator, you probably have a button on your calculator that has pi in it. Okay? All right. I want you to try it here. Find the area and circumference of that circle. And if the area is 24 square feet, find x. You can assume that's a rectangle. All right, take a couple minutes to solve those, and then we'll talk.